Now we will see wave shaping, linear wave shaping and non-linear wave shaping definitions. Okay. So, wave shaping is nothing but we have to send one signal as input to the system. The output of the system we will get by performing some process on the input signal by the system. Then you need to observe the input signal which is applied to the system, and you need to observe the output signal which is coming from the system. When you observe this input signal and output signal, if you have any change in the shape of the signals, then we can tell wave shaping has been done. For example, I am taking one system, this is one system. Here you have given input signal, like step signal you have given as the input signal. If you get output is also step signal, or in some other case you may get exponentially increasing signal, you may get exponentially decreasing signal. So, in these three cases input is same. Okay, input is this unit step signal or the step signal 0 to 5 volts we have given at t is equal to 0, and after t is equal to 0 it is maintaining 5 volts only. This type of signal we have given to one particular system. Then these are the corresponding outputs. In the first case, the shape of the input and output both are same. Okay. So, generally this is input, this is output. So, in the first case shape of the input signal and output signal both are same. When the shape is same, we can say wave shaping has not been occurred. So, wave shaping is not done here. But in the second case, the shape of the signal is the step change at the input side, but the shape of the output signal is exponentially increasing signal. So, here the shape of the output waveform is different from the shape of the input waveform, that is why we can tell wave shaping has been done. In the third case also, the output waveform is actually the exponentially increasing signal and input is step signal. So, the shape of the output waveform is different from the shape of the input waveform, that is why we can tell wave shaping has been done. And in our case, we will use low pass filter and high pass filter. Okay. But before going to that one, now I have given the wave shaping definition to you, and in the textbook you can able to see the definition like this. Wave shaping is the process of altering the shape of the non-sinusoidal input signal, okay, by sending through a system, by sending through a filter or by sending through a circuit is called wave shaping. Simply we can able to understand this one like, if the shape of the output waveform is different from the shape of the input waveform, wave shaping has been done, that is it. But when can we say it is a linear wave shaping and when can we say it is non-linear wave shaping? Very simple thing. If the wave shaping is done because of the linear system, okay, because of the linear system, then we can tell that is a linear wave shaping. If the wave shaping is done because of non-linear system, then we can tell that is a non-linear wave shaping. Very simple thing. System means in our case we can able to use that one as a circuit. So, because of the linear circuit, if you can able to make the shape change of the input signal, then we can tell that is the linear wave shaping. Because of the non-linear circuit, if you can able to make the changes in the shape of the input signal and that changes in the shape you can able to observe at the output signal, then that is called the non-linear wave shaping. Okay. So, we have two types in the wave shaping, one is linear wave shaping and non-linear wave shaping. This classification has been done based upon the type of the circuit which we are using. And in our first module we are using low pass filter and high pass filter for the wave shaping purpose, and these two are involving the linear elements only, that is why these two are linear circuits, linear circuits. So, these two are responsible for the linear wave shaping. In our second module we are going to use clipper circuits and clamper circuits. These are used to get the wave shaping of the input signal, but these two circuits are involving the diodes. Diode is a nonlinear element, as I said earlier. So, these circuits are nonlinear circuits. So, whatever the wave shaping process we are getting because of these clipper circuits and clamper circuits, that wave shaping is said to be nonlinear wave shaping. Okay. Now, we will enter into the first unit now. So, in case of the linear wave shaping, we have understood that one. We have two circuits, one is low pass filter and second one is the high pass filter. Okay. So, here low pass filter, what is the definition for that one? The name itself is giving the information here. It is passing, it is allowing low frequency components of the input signal, and it is rejecting the high frequency components of the input signal. So, allows low frequency components, rejects high frequency components, very simple definition. And coming to high pass filter, high pass, that means allows or passes high frequency components and rejects low frequency components, very simple definition. So, that is nothing but, if you observe the definitions, we are working with frequency components. You can take one system or one circuit, that may be high pass filter or the low pass filter. We are applying here one input signal. This input signal may contain different frequencies. If you remember the Fourier series, we are representing any periodic signal in terms of the cosinusoids or the sinusoids of certain amount of frequencies. Integer multiples of fundamental frequency we have considered in case of Fourier series. That means, if you take one square wave, how many number of frequencies are available here means infinite number of frequencies are there, which are integer multiples of the fundamental frequency n omega naught. If you observe the trigonometric Fourier series expression, for example, a naught plus sigma n changes from 1 to infinity a n cos n omega naught. N omega naught is representing integer multiples of fundamental frequency, and b n sin of n omega naught, again n omega naught. So, we are representing a single signal square wave in terms of so many number of cos functions and sin functions of different frequencies, omega naught, 2 omega naught, 3 omega naught, 4 omega naught, like that. Okay. So, what is the meaning of this one? In the input so many frequencies are there, but if you use here low pass filter, it will allow only low frequency components. Out of so many input components, input frequency components, only few low frequency components will be allowed by the low pass filter. The high frequencies will not come out of the low pass filter. Similarly, if you use here high pass filter, then if you send the input signal of so many frequencies, then only high frequency components will come to the output and low frequency components will be rejected by the high pass filter. Okay. Then this is the definitions point of view I am telling about this one. And before giving the exact circuit of the low pass filter and high pass filter, I am going to analyze the capacitor behavior at different frequencies. As I said just now, we are going to work with frequencies. So, how the capacitor is acting, okay, at different frequencies we should understand. Capacitor is actually based upon the frequency, its impedance is based upon the frequency. The ZC value, that means impedance offered by the capacitor, is given by 1 by j omega c. Okay. That means omega is the angular frequency measured in radians per second, that can be written as 2 pi f. So, 1 by j 2 pi f c is the impedance offered by the capacitor, and we know very well about short circuit and open circuit. Just I am revising here. Short circuit means impedance is 0, open circuit means impedance is infinity. Short circuit means voltage is 0, but current is available, but current is not equal to 0. Open circuit means current is 0, but voltage is existing. In open circuit voltage is existing, in short circuit current is existing. In short circuit, impedance is 0 and voltage is 0. In open circuit, impedance is infinity and current is 0. Okay. These are the basics you should remember. We are going to use these basics several times in our particular subject. So, anyhow, the impedance offered by the capacitor, if you see the formula, we are getting 1 by j 2 pi fc. Okay, 1 by j 2 pi fc. By seeing the expression itself, we can able to come to the conclusion that impedance is based upon the frequency. Okay, impedance is based upon the frequency. For DC signal, frequency is 0. DC means like 2 volts, 5 volts, minus 2 volts, like that. So, for the DC signal, frequency is 0. So, for the 0 frequency, if you take the impedance offered by the capacitor, how much we are getting? 1 by 0 will get. If substitute f is equal to 0, we will get 1 by 0, that is infinity. That means impedance is infinity. Just now I told that if the impedance is infinity, that is nothing but that is representing the open circuit. So, for the DC signal, I am telling very important point now. For the DC signal, frequency is 0. So, that we can understand that the impedance offered by the capacitor Zc is given by infinity. So, that capacitor is acting like a open circuit. It is very important. Okay. That means for the 0 frequency component or for the DC component, DC signal, capacitor is acting as a open circuit. You should remember this one, because directly we are going to use this particular statement in the analysis of the some circuits in coming classes. So, for the DC signal, what is the status of the capacitor? Open circuit. Capacitor will be there in the circuit, we are not removing the capacitor, but capacitor itself is acting as open circuit for the DC frequency. Okay, for the DC signal, capacitor is open circuit. Now, if you take very high frequency, okay, frequency is available means AC signal. So, if you consider that the frequency of that particular AC signal is very high, very large value, we can take infinity also. Okay, infinity means large value only. So, I am taking frequency is very large value. Then if you calculate the Zc value, 1 by very large value means what you will get? Approximately you will get 0 amount of impedance. Okay, 1 by very large value means you will get approximately 0. So, impedance is approximately 0 means the capacitor is acting as the short circuit. So, this is the behavior of the capacitor for the DC signal and for the very high frequency AC signal. Okay. For the DC signal frequency, okay, the capacitor is acting as open circuit. For very high frequency signal, the capacitor is acting as a short circuit. This is what you need to remember. Okay, AC means not only very high amount of frequency. If you take frequency is equal to 50 hertz also, that is nothing but AC signal only. So, I am taking AC with frequency 50 hertz. Then if you calculate Zc, you will not get 0, you will not get infinity, some value you will get. 1 by j 2 pi is some number and frequency is 50, some capacitance we can take 0.01 microfarad or 0.1 microfarad, like that. So, if you calculate this one, you will get some value, it is not equal to 0 and not equal to infinity. That is nothing but capacitor is offering certain amount of impedance. Okay, that is non-zero and non-infinity, like this we can able to tell. So, AC means not only very high frequency, any other frequency, any non-zero frequency can be considered as the AC, but DC means purely we have to take f is equal to 0 only. So, compulsory we can tell for the DC signal, the impedance offered by the capacitor is infinity. So, that capacitor is acting as the open circuit. For DC, capacitor is open circuit. For very high frequency AC, capacitor is short circuit. So, capacitor allows AC content, capacitor blocks DC. This is very important statement. Capacitor blocks DC. Capacitor allows very high frequency AC, very high frequency AC. Okay, I cannot say capacitor allows AC, that may not be true in some cases, because if you take very less frequency, this impedance may not be equal to 0. Okay, for that purpose, for very high frequency AC signal, capacitor is acting as a short circuit. So, capacitor allows very high frequency AC signal, but purely we can able to tell that clearly, we can tell that capacitor blocks DC. Okay. Then now I am going to give the circuit for the low pass filter and high pass filter. So, we can able to tell the low pass filter circuit and high pass filter circuit using active elements also. Okay. We can able to see the concepts of the low pass filter and high pass filter in your subjects in your next year. You can able to get analog electronics, or you may have the IC applications. The subject title may be IC applications. In that you can able to see the low pass filter and high pass filter using operational amplifier also. So, operational amplifier is active element. So, that those are called active low pass filter, active high pass filter. But in our subject we will be having passive low pass filter and passive high pass filter. So, what are the passive low pass filter and passive high pass filter means? These are including the passive elements like resistor and capacitor only. So, very simple circuit, only two elements are there, resistor and capacitor. So, low pass filter means we have to take the series connection of resistor and capacitor like this, and it is grounded. And if you take high pass filter circuit, again series connection of resistor and capacitor is there, and here it is grounded. Both circuits are same, but where we are taking the output, that is different. So, in case of the low pass filter, we are taking the output across the capacitor. So, V naught of t we should take across the capacitor, and in case of the high pass filter, we are taking the output across the resistor. That is why here we have to take the output, and at this particular place we can able to apply the input Vi of t, and in case of the low pass filter, here we can able to apply the input Vi of t, resistor R, capacitor C, resistor R. These are the circuits of the low pass filter and high pass filter. Okay. Now, we will see the remaining part. Okay.